So of course, this brings up another good question. What happens if we choose two vectors that lie on two different lines? For example, let's take the two vectors v with entries 1 and 2 and w with entries 3 and 4. If we plot these two vectors, we can actually see that they definitely do not lie on the same line. So to find the vectors b for which there is a solution to the equation ax equals b, we set up the exact same type of augmented matrix. We put v in the first column, we put w in the second column, then we put two variables, let's say b1 and b2, in the augmentation column. We can multiply the first row by 2 and then subtract it from the second row. Next, we can scale the second row by -1/2. Finally, to put this matrix into reduced row echelon form, we can multiply the second row by 3, then subtract that from the first row. Now that we have the reduced row echelon form, we can think of these as two equations, and we can name our variables, let's say, x and y. The first row tells us that x has to be b1 minus 3/2 times twice b1 minus b2. We can simplify this a little bit. So we get our first coordinate is -2b1 plus 3/2 b2. And our y coordinate is b1 minus 1/2 b2. There are two important pieces of information here. The first piece of information is our original question about consistency. As we can see here, this matrix is always consistent. The second piece of information is the general solution to that linear system. So for example, consider the linear system x plus 3y equals 2 and 2x plus 4y equals 4. Our answer tells us, if we think about the number 2 as our b1 and the number 4 as our b2, all we have to do is plug those numbers into the vector that we have written above. And we can check that if we plug the number 2 in for x and the number 0 in for y, we do in fact get a solution to our original linear system. So returning to the original piece of information that we got from our reduced row echelon form, the linear system a times x, which is given by the matrix with columns v, whose entries are 1, 2, and w, whose entries are 3, 4, times the vector xy is equal to b1, b2. The fact that this has a solution for every single choice of b1 and b2 tells us that the span of the vectors v and w is the entirety of R2. So this difference between the two, so in our first example, we had a pair of vectors which lie on the same line. And in our second example, a pair of vectors that do not lie on the same line will bring us to our next topic, which is that of linear independence, which we'll cover in the next video.